Yeah, so we have a meeting at 9 and then we're gonna do our experiment after. We could do that around, wait, Mr. Urban, what time is it?
I don't know, the clock's right there.
Well, what the heck? It doesn't have any power.
What does the clock need for power?
Let's find out. What's up, seahorses? It's Miss Martinez.
And Mr. Urban. For today's experiment, we need to figure out how to power this clock.
Let's go do some research and get down to it.
After some research, we discovered that electronics require circuits. Circuits are a complete pathway for electric currents to move through. An electric current is a stream of charged particles, such as electrons or ions, moving through an electric conductor or space. And we discovered most fruits have electrolytes. So we decided to try to make a circuit out of fruits. Let's try it. For this experiment, we are going to need potatoes, oranges, lemons, LED lights, and a clock.
This clock has both a red wire and a black wire. The red is for positive and the black is for negative. So we want to connect those same wires to those same sides. Red with red and black to black. This will help us conduct the electricity. There we go.
For the circuit to work, it must be a complete circuit, which means it's basically a loop, and it all must be connected. So positive to positive, negative to negative, and stab it in the orange. Do you think it's gonna work? Let's find out. No power yet.
No power with just one orange, so let's add some more and some lemons. We got the positive side coming in on the left, and towards the right side we have the negative charge. So we're just making sure that those loops are secure, those connections are secure, and stabbing that fruit. And yeah, we got some power. So that positive side is on the left with the red, and the negative side is on the right with the black. Once we disconnect and connect, we got that power and no power when we disconnect.
Now that we know we have some power coming from the lemons and oranges, let's try to light up an LED. Positive to positive, and negative to negative. No power.
We know the fruits work, so let's try some potatoes next. We know we're gonna need a lot of power, so let's get those potatoes in line. Same rule still applies. Start with the positive on the left and the negative on the right. You want to make sure you get those conductors nice and in there, right in the middle of the potato. Let's see if it's gonna work. Make sure you clamp those clamps onto the wires nice and securely. No power.
Well, let's add some more potatoes. Let's see if we can conduct any electricity from them. Since we're adding on the left side, we want to use positive wires. Conductor is nice and secure. And let's give it a try. Positive to positive, negative to negative. And we have power from potatoes. Wow. So if you guessed that potatoes would have worked, good job.
Now that we know the clock work, let's try some LED lights. This light was not working for us, so we thought we'd try another one. Maybe the LED light was broken. Nope, still no success.
Alrighty, seahorses, for this experiment we are going to be dropping 4 items from the top of this playground, and we're going to see if they fall at different speeds or do they fall at the same speed.
We got a scarf, wiffle ball, basketball.
And why not? Let's drop a pool. Let's see what happens.
Which object do you think will fall the fastest? The distance was 3 meters.
So, cloth,
Scarf.
scarf.
Ready? 3, 2, 1.
3 seconds exactly.
Okay. Ready? 3, 2, 1.
0.65 seconds.
3, 2, 1.
0.66.
Ready? 3, 2, 1.
1.4.
3, 2,
2.19.
3, 2,
0.55.
3, 2, 1.
0.65.
3, 2,
0.84. Oh, yeah.
3, 2,
1.77.
3, 2, 1.
0.65.
3, 2, 1.
0.73.
3, 2, 1. I wish I would have known that those were in the shed. I could have totally used that for my boat. But I
To find the average time it took to fall, we added them together and divided by 3. The scarf was 2.32 seconds. The wiffle ball was 0.62 seconds. The basketball was 0.68 seconds. And the average for the pool was 1 second falling time. So, if you picked the wiffle ball, you were correct. The wiffle ball fell the fastest.
How cool that we were able to conduct electricity from fruits and vegetables today. Maybe you could try this at home with some of your own fruits and vegetables.
And also, for the gravity experiment, the wiffle ball was the fastest. And that is due to the least amount of air resistance. The pool especially, and the cloth would catch the air as it was falling down, but since the wiffle ball only had holes, it would just fall straight to the ground. How cool is that? See you later, seahorses.